Along the southern banks of the River Thames, where luxury apartments and modern glass towers now dominate the skyline of London, there stands a structure that once powered an entire empire. For decades, Battersea Power Station was one of the most powerful industrial machines in Britain. Its gigantic boilers consumed thousands of tons of coal every single day. Its four massive chimneys released dark smoke high above London. And at its peak, this colossal facility supplied nearly one-fifth of the electricity for the entire capital. But eventually, Britain's industrial age began to collapse. Coal power stations became outdated, heavy industry disappeared from the city, and Battersea Power Station slowly transformed into something else entirely. An abandoned shell, a decaying monument, a gigantic ruin sitting directly beside one of the most valuable rivers in Europe. For decades, multiple redevelopment plans failed. Developers ran out of money, ownership changed repeatedly, parts of the structure continued to deteriorate, the roof disappeared, rain entered the turbine halls, steel corroded, concrete cracked, and many people believed the structure would eventually be demolished forever. But instead of destroying it, London launched one of the most ambitious urban regeneration projects in modern European history. A redevelopment campaign lasting more than 12 years, costing approximately $9 billion, transforming a collapsing industrial relic into an entirely new district built for the 21st century. More than 4,000 engineers, architects, construction workers, and restoration specialists became part of the operation. The project required the complete dismantling and reconstruction of all four iconic chimneys, the insertion of entirely new floors and structural systems inside a nearly hollow shell, the restoration of historic industrial interiors, and even the extension of a new underground railway directly to the base of the power station. Today, Battersea Power Station is no longer a dead industrial complex. It has become one of London's newest urban centers, filled with offices, luxury apartments, retail spaces, restaurants, observation experiences, and millions of visitors every year. But rebuilding Battersea was far more complicated than constructing a completely new building from the ground up, because the engineers were forced to preserve history while simultaneously building an entirely modern city inside it. In today's MegaBuild HQ documentary, we explore how London revived one of the world's most famous industrial structures and transformed it into a $9 billion mega district. Battersea Power Station was once one of the largest coal-fired stations in the United Kingdom. Constructed in multiple phases between the 1930s and the 1950s, the enormous facility stood directly beside the River Thames in southwest London. The location was strategically chosen. Coal could be transported efficiently by river barges, electricity could be distributed directly into central London, and the massive structure itself quickly became one of the most recognizable industrial landmarks in Britain. At the peak of operation, Battersea Power Station generated enough electricity to power nearly 20% of London. Inside the building, gigantic turbines converted steam pressure into electrical energy. Massive boilers burned huge quantities of coal around the clock. Workers continuously maintained equipment operating under extreme temperatures and pressure. For decades, this industrial machine helped power the modernization of London. But industrial technology evolved rapidly after the Second World War. Cleaner and more efficient energy systems gradually replaced coal-fired stations. Operating costs increased, environmental concerns intensified, and eventually, Battersea Power Station became economically unsustainable. The station finally ceased operations during the 1980s. After closure, the structure entered a long period of abandonment. The interior deteriorated severely. Sections of the roof were removed. Rainwater damaged the internal steel framework. Large portions of machinery were dismantled and removed, and despite its architectural significance, no redevelopment plan succeeded for decades. Developers proposed shopping centers, theme parks, entertainment complexes, and commercial redevelopment schemes, but nearly all of them collapsed before construction could begin. Meanwhile, Battersea remained frozen in decay, a gigantic industrial skeleton beside the Thames. However, in 2012, a massive redevelopment campaign was officially launched. This was no longer simply a restoration project. It became the foundation of an entirely new urban district. The redevelopment covered approximately 42 acres, and the plan required transforming the former power station into a mixed-use urban center containing office space, retail areas, luxury residences, public plazas, restaurants, event venues, and tourism attractions. The enormous turbine halls would become commercial spaces. The former boiler house would be transformed into multi-level office areas. Historic industrial interiors would be restored, and the famous chimneys, perhaps the most recognizable feature of the entire structure, would be completely rebuilt. The redevelopment also triggered major infrastructure expansion throughout the surrounding district. New residential towers began rising around the site. Road systems were redesigned, public spaces were introduced, and most importantly, London extended the Northern Line Underground Railway directly to Battersea. The project was no longer simply about preserving a historic building. It became an attempt to reshape an entire section of the city. But before any luxury apartments or retail spaces could open, engineers first had to solve one enormous problem. The power station itself was dangerously deteriorated, and nowhere was that deterioration more severe than inside the four iconic chimneys. Rising more than 100 meters above London, the four white chimneys of Battersea Power Station became one of the most recognizable industrial silhouettes in Britain. For decades, these massive structures released smoke from the giant coal boilers operating below. But after years of abandonment, the chimneys had become one of the most dangerous parts of the entire structure. Concrete surfaces had cracked, moisture had penetrated deep into the structure. Steel reinforcement inside the concrete began to corrode, and structural inspections revealed severe deterioration throughout the shafts. Engineers discovered that simple repairs would not be enough. The chimneys had lost too much structural integrity, and modern safety standards could no longer be guaranteed. As a result, one of the most difficult decisions of the project was made. All four chimneys would be completely dismantled, then entirely rebuilt from the ground up. However, demolishing industrial chimneys in central London created enormous engineering challenges. Normally, large industrial chimneys can be destroyed using explosives, but Battersea Power Station stood in the middle of a dense urban environment beside the River Thames. Luxury neighborhoods, road systems, rail infrastructure, and surrounding developments made controlled explosions impossible. Instead, engineers adopted a highly controlled top-down dismantling process. Each chimney was surrounded by a massive scaffold enclosure extending almost the entire height of the structure. This enclosure controlled falling debris, reduced dust pollution, and minimized vibration throughout the surrounding area. Workers then dismantled the chimney section by section. Concrete fragments were carefully removed from the top downward. Every stage of demolition had to remain precisely controlled, because any instability inside the shafts could threaten both workers and the surrounding structure. Once dismantling was completed, engineers began rebuilding the chimneys using modern reinforced concrete systems. But despite using modern engineering technology, there was one major restriction. The rebuilt chimneys had to appear almost identical to the originals. Heritage conservation authorities demanded strict visual accuracy. Even small details mattered. The texture of the concrete, the proportions, the surface appearance, and the distinctive horizontal banding visible around the shafts. To recreate these historical characteristics, engineers intentionally copied construction methods from the 1930s. Instead of relying entirely on modern concrete pumping systems, materials were transported upward using hoists. Workers manually moved concrete using thousands of wheelbarrows. Concrete was then poured into circular formwork layer by layer. This slower process recreated the subtle surface lines visible on the original chimneys. An extraordinary amount of effort was invested into preserving visual authenticity, even though the structures themselves were entirely new. Specialized protective coatings were later applied across the exterior surfaces. These coatings increased resistance against moisture penetration, weather exposure, temperature variation, and long-term urban pollution. The final result became almost impossible to distinguish from the historic chimneys that once stood there. From a distance, Battersea's skyline remained visually unchanged, but internally, the chimneys had been completely reborn using modern engineering standards. Yet one chimney would eventually receive an even more unusual transformation, because inside one of these historic industrial towers, engineers planned to install a modern glass observation elevator. After rebuilding the outer shell of the chimneys, engineers moved to one of the strangest mechanical engineering challenges of the entire Battersea project: installing a passenger elevator inside a chimney. At first glance, the idea sounded relatively straightforward, but the geometry of the chimney created a major complication. The chimney was not perfectly vertical. Its diameter gradually narrowed toward the top. Meanwhile, an elevator system requires perfectly vertical movement. The guide rails cannot shift inward as the chimney narrows. In addition, traditional elevator systems normally place heavy machinery at the top of the shaft. But adding large mechanical loads to the top of Battersea's chimney would create structural complications. It would also block the panoramic observation experience engineers wanted to create. To solve these problems, the engineering team developed an unusual solution inspired by historical European observation elevators. Instead of positioning the drive machinery above the cabin, a massive hoisting system weighing several tons was installed at the base of the chimney. This system operated using a looped cable configuration. Steel cables traveled upward to a reinforced ring structure at the top of the chimney. The cables then looped back downward and connected to both the elevator cabin and counterweight. This configuration allowed the heavy machinery to remain at ground level, reducing stress on the upper chimney structure and preserving a fully transparent observation ceiling at the top. But another challenge still remained. Because the chimney walls gradually narrowed as they rose upward, engineers could not simply attach elevator rails directly onto the concrete surface. Instead, adjustable support brackets were installed throughout the shaft. These brackets compensated for the changing geometry of the chimney and allowed the guide rails to remain perfectly vertical from bottom to top. The installation process itself was extremely delicate. Workers operated in a narrow, cylindrical environment extending more than 100 meters upward. Large steel components had to be lifted precisely through the confined shaft. Alignment tolerances remained extremely strict. Even small deviations could affect passenger safety and operational stability. Eventually, a transparent glass elevator cabin was successfully installed. The system could transport approximately 30 passengers at a time, and the elevator could rise more than 100 meters above London in less than half a minute. Today, this unique observation elevator has become one of the most unique tourism experiences in the entire redevelopment. Visitors now travel upward through the interior of a historic industrial chimney, inside a structure that once released coal smoke above the city. But while the chimneys became one of Battersea's most visible restoration challenges, the far larger engineering operation was happening inside the building itself, because engineers were preparing to rebuild an entire modern urban structure inside the shell of a nearly century-old power station. Rebuilding Battersea. Battersea Power Station is one of the largest brick buildings ever constructed. The enormous structure contains millions of bricks, gigantic industrial halls, massive steel frameworks, and interior spaces originally designed for turbines and coal boilers. But after decades of abandonment, most of the internal systems had disappeared. Large sections of the roof were gone, floor systems had been removed, machinery no longer existed, and rainwater had severely damaged parts of the structure. In many ways, engineers were not renovating a building, they were constructing an entirely new city inside an empty industrial shell. One of the biggest challenges involved the creation of new floor systems. The original power station contained enormous vertical industrial spaces, but the redevelopment required office areas, luxury apartments, retail centers, restaurants, and event venues. This meant engineers needed to insert multiple new structural levels inside the existing volume. However, the redevelopment created a major contradiction. The upper levels could use conventional support columns, but the lower commercial spaces needed to remain wide and open. Dense columns would reduce flexibility for...
Battersea Power Station is one of the largest brick buildings ever constructed. The enormous structure contains millions of bricks, gigantic industrial halls, massive steel frameworks, and interior spaces originally designed for turbines and coal boilers. But after decades of abandonment, most of the internal systems had disappeared. Large sections of the roof were gone, floor systems had been removed, machinery no longer existed, and rainwater had severely damaged parts of the structure. In many ways, engineers were not renovating a building, they were constructing an entirely new city inside an empty industrial shell. One of the biggest challenges involved the creation of new floor systems. The original power station contained enormous vertical industrial spaces, but the redevelopment required office areas, luxury apartments, retail centers, restaurants, and event venues. This meant engineers needed to insert multiple new structural levels inside the existing volume. However, the redevelopment created a major contradiction. The upper levels could use conventional support columns, but the lower commercial spaces needed to remain wide and open. Dense columns would reduce flexibility for retail layouts and public movement. To solve this problem, engineers implemented massive transfer beam systems. Wide-flange steel beams capable of resisting extremely large bending forces were installed throughout the structure. These beams transferred loads from upper levels into carefully controlled support points below. One critical steel beam measured approximately 27 meters in length and weighed more than 60 tons. This single structural element supported loads transferred from multiple levels above. At the same time, engineers used specialized steel transfer tree systems. In this configuration, multiple upper columns transferred loads into a smaller number of support points below. The result allowed lower commercial floors to remain visually open, while upper residential and office areas maintained structural stability. The installation of these components inside an existing heritage structure required extraordinary coordination. Large steel elements had to be lifted carefully into the building. Temporary supports stabilized sections of the structure during installation, and engineers constantly monitored load behavior throughout construction. Meanwhile, restoration teams worked to preserve key industrial interiors. One of the most important spaces became Control Room A. Originally constructed in the Art Deco style during the 1930s, this room once controlled the entire power station. Historic control panels, mechanical switches, load meters, and decorative surfaces were carefully restored. Many original components were dismantled, cleaned, repaired, and reinstalled in their exact historical positions. The goal was not simply architectural preservation. Engineers wanted visitors to experience the atmosphere of Battersea's industrial past. At the same time, other parts of the structure underwent complete modernization. New electrical systems, climate control, fire safety systems, digital infrastructure, and modern building services were integrated throughout the redevelopment. One of the most famous additions eventually became Apple's major London office. Thousands of employees moved into office spaces built directly inside the former boiler house.
What once generated electricity for London now housed one of the world's largest technology companies. But transforming Battersea into a functional urban district required more than architectural restoration, because millions of future visitors would need transportation access, and for decades, that had been one of the biggest weaknesses of the entire location. One of the most important engineering projects connected to Battersea Power Station was not located inside the building itself. It was happening underground. For decades, Battersea remained relatively isolated from London's underground transport network. Despite its position beside the River Thames, large-scale urban redevelopment remained difficult without direct metro access. Developers understood a simple reality. If millions of people were expected to visit the district every year, transportation infrastructure had to expand dramatically. As a result, London launched the Northern Line Extension project. The Underground Railway would be extended approximately 3 kilometers directly toward Battersea. 2 entirely new stations would be constructed, 9 Elms and Battersea Power Station. This became one of London's most significant underground expansion projects in decades. Tunnel boring machines were deployed beneath densely populated sections of the city. Engineers excavated tunnels through London clay, a geological layer commonly found beneath the capital. But tunneling beneath an active urban environment always creates enormous technical challenges. The excavation process had to avoid damaging existing underground infrastructure, building foundations, utility systems, and surrounding transportation networks. Tunnel boring machines advanced gradually through the subsurface. Segments of reinforced concrete tunnel lining were installed behind the machines as excavation progressed. Ventilation systems, emergency access systems, drainage, power infrastructure, and station platforms were later constructed inside the new underground spaces. Meanwhile, engineers designed Battersea Power Station directly beside the redevelopment. The goal was not simply transportation efficiency. The underground extension became part of the district's identity. Passengers could now travel directly from central London into a regenerated industrial mega-district built beside the Thames. The new stations also triggered broader development throughout the 9 Elms area. Residential towers rapidly appeared, commercial investment increased, public spaces expanded, and land values throughout the district rose significantly. Transportation infrastructure had transformed the economics of the entire redevelopment. Without the underground extension, Battersea might have remained isolated. But with direct metro access, it became fully integrated into London's modern urban system. Eventually, after years of restoration, structural engineering, infrastructure expansion, and massive construction operations, Battersea Power Station approached its final stage: testing, commissioning, and opening. After more than a decade of construction, Battersea Power Station finally entered its final operational phase. But before the district could officially open, engineers needed to test an extraordinarily complex combination of systems. This was no longer simply a building. It had become an entire mixed-use urban environment. Electrical systems, ventilation, elevators, retail infrastructure, public access routes, fire protection, climate control, transportation connections, and structural systems all required extensive testing. Thousands of people would soon occupy the redevelopment every day, which meant safety and operational reliability became absolutely critical. Engineers conducted commissioning procedures throughout the district. Mechanical systems operated continuously under controlled conditions. Emergency systems were tested repeatedly. Passenger flow simulations examined movement patterns inside retail areas and public spaces. Meanwhile, restaurants, retail brands, office tenants, and tourism operations prepared for opening. One of the biggest attractions became Lift 109. The glass elevator observation experience inside the chimney quickly attracted enormous public interest. At the same time, the restored turbine halls became some of the most visually distinctive commercial interiors in London. Historic industrial architecture blended together with modern lighting, retail spaces, restaurants, and public gathering areas. Finally, in 2022, Battersea Power Station officially opened to the public. The response was enormous. Hundreds of thousands of people visited during the first opening period alone. Within the first year, millions of visitors entered the redevelopment. The former industrial ruin rapidly transformed into one of London's most active urban destinations. More than 100 shops, restaurants, experience centers, and commercial spaces began operating inside the structure. Public plazas filled with visitors. Office workers occupied newly completed workspaces, and the surrounding Nine Elms district continued expanding around the redevelopment. Perhaps the most remarkable transformation was psychological. For decades, Battersea represented industrial decline, a reminder of abandoned infrastructure and failed redevelopment. But after the opening, it became a symbol of urban reinvention, an example of how historic industrial architecture could be integrated into the economy of a modern global city. The project demonstrated that regeneration did not always require demolition. Sometimes, a city could preserve its industrial identity while simultaneously creating something entirely new. For nearly 100 years, Battersea Power Station has remained one of the most recognizable structures in London. It witnessed the rise of Britain's industrial age, the transformation of modern electricity networks, the decline of coal power, and decades of abandonment beside the River Thames. At one point, many believed the structure would disappear forever, but instead of demolishing it, London chose something far more difficult: rebuilding it. The project required the complete reconstruction of all 4 chimneys, the insertion of entirely new structural systems inside a historic shell, the restoration of Art Deco industrial interiors, and the expansion of a major underground railway directly to the site. Engineers were forced to balance preservation, modernization, commercial development, and urban infrastructure simultaneously. Today, Battersea Power Station is no longer simply a former coal plant. It has become a functioning urban district operating 7 days a week. Millions of people now visit the redevelopment every year. Office workers occupy spaces that once contained giant coal boilers. Tourists ride elevators through industrial chimneys. Restaurants and retail areas fill halls that once generated electricity for London. And the surrounding Nine Elms district continues evolving around the project. Perhaps most importantly, Battersea demonstrates how industrial structures from the 20th century can be adapted for the future rather than erased from history. Because in modern cities, restoration is no longer simply about preserving old buildings. It is about transforming forgotten infrastructure into entirely new economic systems. And Battersea Power Station may be one of the clearest examples of that transformation anywhere in the world. If you enjoyed this MegaBuild HQ documentary and want to explore more of the world's most ambitious engineering projects and urban megastructures, make sure to subscribe for more cinematic deep dive documentaries. Because around the world, there are still giant projects being built, rebuilt, and transformed on a scale most people never truly see.